Alright, so today we're going to talk about periodic graphs and phase shifts. The distance that one graph must be shifted to the right or to the left to coincide with another graph is called a phase shift. Consider the parent functions of sine and cosine. What phase shift would we need to make the cosine graph equal the sine graph? So let's go ahead and take a look at some transformations I got here. So if we look at this graph here, we know that A is our amplitude, B is going to be changing the frequency, C is the phase shift, and D is our midline. So for our C value, if let's say this is a sine graph and we wanted to make this into a cosine graph, so we'll do sine into cosine first, then how would I have to change this graph? So if I were to notice that if I move my C value left to right, this is why we call it a phase shift, because it kind of phases into itself and looks the same. So if I shift this graph to here, so if I go from taking this point to the left pi over 2, so if I move sine to the left pi over 2, notice it looks like my cosine graph starts at 1, and then we have 0, -1, 0, 1. So if I go to here. So if we want to shift the sine graph to make a cosine graph, then again, we just said we would move our sine graph left pi over 2. So what does that look like in an equation? So the sine of x, and remember when we're going to the left, it's minus -pi over 2, so this would become plus pi over 2. That would give us our cosine of x graph. So similarly, if I go back to my graph here, if I move my graph from cosine from here back to the right pi over 2, notice it would give me my sine graph. So that's what our phase shifts looks like. So going back to here, so if we move our cosine graph to the right pi over 2, then our graph will look like the cosine of x minus pi over 2 is equal to the sine of x. So those are the shifts that we would move sine and cosine and vice versa. So combined transformations. So this is when a is not equal to 0 and b is greater than 0, then each of the functions have these certain characteristics. So remember, a stands for the amplitude, B stands for the period changes, so it's going to be our frequency of our graph. C gives us our phase shift, which is nu, and then the D value is going to be our midline. So notice for this graph that we have over here, we took their sine graph and we moved it to the right. So this C value is the phase shift. And it says the absolute value of A for the amplitude, because that's, remember, a distance, the midline, and then from here to here tells us the period. So our key points, remember, when our A value is bigger than 0, we start at 0. So if we're not, this is saying we're not shifting it up or down at all, so we would start at 0. So this means we're looking at our Y values. So our Y values would start at 0. Then they go up to the high point. So this would be 0, high point, 0, low point, and then 0. So 0, high point, 0, low point, 0. So O holo. And if you were to have an A value with a reflection, it would start at 0 and then go the opposite direction to low, back to 0, high, 0. And so that would give us our equations. And so we can kind of think of the same thing for our cosine graph. So again, shifting from a max to min, shifting it over left or right, that's going to be our cosine graph. So notice it starts at high. So we start high, origin, or our Y value 0. So this would be low, 0, and then high again. So high, 0, low, 0, high. And then if we had a reflection, it'd be low, 0, high, 0, low. So holo, if you want to think about it. So however you want to make sure you know that. I always just like to think about the unit circle to help me. So our A value, guys, our amplitude, the new period is 2 pi over B, because remember that B times the period equals 2 pi. The phase shift is C, vertical shift D. So some helpful ways to remember the equation from a graph. So if your amplitude is your y maximum minus your y minimum divided by 2, your midline is your y max plus your y min divided by 2. Your B value is 2 pi over, and that should say the period. Sorry, I didn't realize I wrote B there again. So 2 pi over the period. And then your C value for sine, remember sine starts on the midline. So if we think about our sine graph starting on the midline right here, and that means then you're looking at your x values that are in between a max and a min. So if you don't know where it's at, you could always take the x maximum plus x minimum divided by 2 to find the middle of the two, or the average. And then for the cosine graph, notice cosine graphs always start at a max or a min value. So we could just use the max or min to help us figure out a cosine graph, because we're going to have to be able to do both. So then for the next part, it says determine the period, amplitude, midline, phase shift to key points for this equation. So the amplitude is absolute value of that A value. So this would be 1/3. So this is your A value. This would be our B, C, and D. So in order to find the period, we have to know what our B value is. But notice that here it's not in factored form. So the first step I should have done actually should have been to factor out that B value. So 1/3 times the sine of -2 times t. And when we're dividing that B value out, that means we're dividing it out of the -5 as well. So this would be -5 halves. And so since you're taking out the -2, that would actually become +5 halves. Because if you think about distributing this -2 back in, this would be -2 times t, and then -2 times 5 halves would give us -5, and then +7. So that means our B value is -2. This would be our C and our D. So for the period, remember B times the period equals 2 pi. So the period is equal to 2 pi over the absolute value of B. We don't ever use the negative. So I should probably come up here and write the absolute value of B, where it says new period 2 pi over the absolute value of B. So going back down here. So because our B value is negative, it doesn't make our period negative because remember it's a distance. So in this case, we get 2 pi over the absolute value of -2, which means that our period in this case is pi. The phase shift is -5 halves. Remember, it's always opposite because that moves it to the left. 5/2, which is negative. Midline is at y equals 7 because that's our D value. And our key points, we take the period and divide it into 4 equal parts. So key points are going by interval units of pi over 4. So that would be our equations. The next example, say we want to write the sine function when the amplitude is 3, the period is 3 pi, and the phase shift is -1/3. So the amplitude is 3, the period is 3 pi, and the phase shift is -1/3. So our general equation, y equals a times the sine of b times x minus c, and then plus d. So we're always using that factored form for our equation. So we get y is equal to 3 times the sine. We don't know our b value until we solve. So we know that, again, b times the period equals 2 pi. So the b value equals 2 pi divided by 3 pi, because it's 2 pi over the period when you solve. So you get 2/3. So then this would give us 2/3. And then parentheses x, and our phase shift is -1/3. So if you have minus -1/3, remember that becomes a plus. So I'm just going to write plus 1/3. And then there was no shift up or down, so this would be my equation because we didn't have a midline change from 0, didn't say. So next one, we're writing a cosine function when the amplitude is 2, the period is pi, and the phase shift is 5. So again, if our period is pi, then we need to find the b value, which is 2 pi divided by the period. So 2 pi divided by pi is equal to 2. So y equals a times the cosine of b times x minus c plus d is a general equation. So y equals a, which is 2, times the cosine of our b value, which is 2 times x minus 5. And then we didn't have a midline in this case, so that would be our equation. All right, next part is to write a sine and cosine equation for the graph below. So for these types of problems, there really is an infinite amount of equations you could write, because you could always start a cosine on any of the maxima mins, and you can always start a sine graph on where the midline is. So first, to write the equation, we want to find our max and our min value. So our maximum here is 2, and our minimum is -2. So that means that the amplitude would be 2 minus -2, maximum minus minimum divided by 2, which gives us 4 over 2, which is 2. The midline would be 2 plus -2 divided by 2, which gives us 0 over 2, so 0. So here's our midline. And that makes sense because if you count up 2 and down 2, you get 2 for the amplitude. To remember to find the period, you have 5 key points in one wavelength. So on the y-axis, our graph is below, so this looks like this would be at the start of a cosine graph. So we have 1, 2, 3, 4, 5 key points. So notice from 0 to 4 would be the period then for our 5 key points. So then we know that, again, b times the period equals 2 pi. So b is equal to 2 pi divided by 4, which gives us pi over 2. So that would be my b value. So now that I have this information, I can go ahead and start to write my equations. Now again, like I said, remember that we can write an infinite amount of equations for this depending on where we start. So let's start with cosine, because cosine graphs either start on a minimum or a maximum. So let's start with the minimum down here first. If we start here, then we wouldn't have phase shift because we're starting on the y-axis. So one possible equation would be y equals, my amplitude is 2, but it's starting down first, so -2 times the cosine of parentheses, and then we have our b value, which is pi over 2 times x, or you could write pi x over 2, doesn't matter how you write that. And then we don't have a midline, so that would be one possible cosine equation. Let's say we started the cosine equation up here instead. Then my equation would be y equals 2. We wouldn't need a reflection because we're starting at a maximum, times the cosine of pi over 2. And this one, because it's not starting at where our paragraph would start on the y-axis, we're moving to the right 2. So that means then this would be a phase shift to the right 2 would be -2. And then again, there is no midline. So let's say instead we started with this one over here for our cosine graph. Then this would be y equals 2 times the cosine, and again it's at a maximum, so we don't need the reflection, of pi over 2 times x plus 2, because this one's moving to the left 2. So it just depends on where you start. So these are all possible cosine equations. So then our sine equation starts on the midline. So this would be a possible sine equation here. So one possible sine equation, notice it starts the midline and goes up. So that would be y equals 2 times the sine of pi over 2. And the phase shift, notice your x axis is going by values of 1. So that would be x minus 1. If we started our graph here instead, so then this would be y equals 2 times the sine, and actually because it goes down first, we would need negative, so this would be -2 times the sine of pi over 2 times x minus 3. So if we were to graph all of the equations on a graph, each equation would give you this same graph right here. And again, those are other places I could have used sine. I could have used sine here, or here, or here. Anywhere it crosses the midline, I can use a sine equation. So those are all possible equations for the graph. So why don't you pause the video and then see if you can do this next one on your own. When you're done, unpause it to check your work. So for this one, the maximum's at 9. The minimum, it looks like it's at -3. And so that means then the amplitude would be 9 minus -3 divided by 2. So 12 over 2, which is 6. And then the midline would be 9 plus -3 divided by 2. So 6 divided by 2 gives us a midline of 3. And I always like to draw the midline on the graph, so it would be right here. Now this one's a little bit harder for the period because if I start at my maximums, it's not starting, notice a max, not starting with the y-axis on the midline or on a max or min. So that means I have to have a phase shift for my equation no matter what. And I also don't see a full wavelength, because if I have a maximum here, that's 1, 2, 3, and this would be 4 key points, and I can't see the fifth one. So how do I figure out the period? So from a max to min or min to max, that's half of a wavelength. So this is 1/2 of a wave. So I can figure out that distance and multiply it by 2. So 1/2 of the wave is equal to a distance of, and notice that our x-axis scale is going by 0.5. So this is right here, -2.5, and then this here is at 0.5. So 0.5 minus -2.5 is 3. So the distance from there to there is 3. So then that means a full wave is 2 times 3, which equals 6. So the period is 6. So then the B value would be B times the period equals 2 pi. So B equals 2 pi divided by the period, which is 6. So our B value is equal to pi over 3. So now I can go ahead and start writing my equations. We again want a sine and a cosine graph. So this would be a cosine graph here, and this would be a cosine graph down here. And notice that you have to have a phase shift no matter what, because we're not starting on the y-axis on a key point. So we have y equals, if I do the -1 first, so y equals my amplitude, we said was 6, and it's starting at the maximum, so 6 times the cosine of my b value is pi over 3 times x, and it's going to the left, -2.5, so this would be plus 2.5. And then my midline is at 3, so plus 3. So that's one possible equation. Another possible equation, if we use this minimum down here, would be y equals -6 times the cosine. We're using negative because it's starting at a minimum. Pi over 3 times x minus 0.5, because we're moving to the right, 0.5 plus 3. So that would be another possible cosine equation. For sine, I could start here, would be one way. So y equals, because it goes down instead of up first, it would mean -6 times the sine of pi over 3, because it's my b value, times x. And we're going to the left one, so minus -1 would be +1 plus 3. And let's say I started my sine equation here, then this would be y equals, and since it's going up from there, this would be 6 times the sine of pi over 3 times x, or not plus, sorry, because we're going to the right, -2 plus 3. So those, again, are just the possible equations that I got from looking at this graph. And of course, there's an infinite many amount of possible answers, because you could continue the graph on. So now that we have experience with writing the equations and writing the equations from the graph, we can go ahead and graph our functions. So the first thing you should always do when you are graphing is factor out that b value if it's not in factored form. So I notice right away that this b value is not in factored form, so I want to factor that out. So if I factor out my b value, I have y equals 3 times the cosine of 1/2, and this would be t. When you factor something out, you're dividing it out. So if I have pi over 2 and I'm dividing out 1/2, keep change flip. So pi over 2 times 2 over 1 means that inside here would be t minus pi. And an easy way to check is to think about distributing that b value back in. So 1/2 times t would be 1/2 t. 1/2 times -pi would be -pi over 2. So my a value here for my amplitude is 3. My b value is 1/2. My c value is pi, because we're going to the right, pi, and my d value is -2. So then the period, again, b times the period equals 2 pi. So the period equals 2 pi divided by b. So 2 pi divided by 1/2, keep change flip. So 2 pi times 2 over 1 gives me 4 pi. Then for my key points are the period divided into 4 equal parts. So it's going by intervals of pi on my graph. So this would be 1 pi, 2 pi, 3 pi, 4 pi, etc. forget to label your x-axis all the way and your y-axis as well. So we have our midline is at -2, so that would be here. So we should use dotted line. So this is our midline. And then for this, this is a cosine graph. So normally, since it's no reflection, it would start above the midline up 3. So 1, 2, 3 would be here. But because we have a phase shift to the right pi, instead of starting there, I'm actually going to start my graph here. So this is where I'm starting. Circle that point. And that's because of the phase shift. So then from there, we go back to the midline, down 3, back to the midline, up 3. So this would be the first cycle of my graph. So again, what happened was you can do all the transformations separately if you want, but we went from here and we moved it to the right pi. So it's going to be at this point instead. So I'm going to take that point out. So if we want another cycle, we would just continue that pattern. Oops. The next one would be off our graph here. We would go to 9 pi, and then we go the opposite direction. So that would be 3 cycles then. All right, so let's go ahead and graph the next one. So for this one, again, you want to factor out that b value. And so if I factor out the b value, remember you're dividing out, so this becomes a phase shift of pi over 4. So our amplitude is the opposite value of -2, which is 2. Our b value is 4. Your c value is pi over 4, so we're going to the right. Our d value is 3. So the period is equal to 2 pi over b. So 2 pi over 4 is equal to pi over 2. So then the key points would be equal to the period divided by 4 times the fourth is the same thing, so pi over 8. So on my graph, I like to a lot of times write the intervals for the units that I'm changing my key points up here and then reduce them. So 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8, 6 pi over 8, 7 pi over 8, and 8 pi over 8. And then I like to reduce them on the x-axis. So 1 pi over 8, 2 pi over 8 is pi over 4. So 3 pi over 8. And then 4 pi over 8 is pi over 2. 5 pi over 8. 6 pi over 8 is 3 pi over 4. 7 pi over 8. And then pi. So on my graph, we have our midline at 3. And then for my graph, this is a sine graph, so normally it starts on the y-axis on the midline, except for we have a phase shift of to the right pi over 4. So instead of starting here, I'm going to shift that point to the right pi over 4. So I'm actually going to start the point right here. I like to circle it just so I remember. So the sine graph normally goes up the amplitude from that point on the midline, but because of the negative, we're going to go down 2, then back to the midline, up 2, back to the midline. So that would be my first wavelength with the phase shift. So if I go the negative direction, this would give me 2 cycles of my graph. And again, we started here from a graph. And I could continue my graph if I wanted to, but I'm not going to get another full cycle. This would just be a half of the cycle here, and this would be another half of the cycle. Okay, so why don't you go ahead and pause the video and see if you can do this last one on your own. When you're done, you can unpause to check your work. Again, factor out that b value. So we have 3 times the cosine, and then this becomes pi times x minus. And we're dividing out pi. So since we're dividing out pi, that then becomes minus be 1/2. And I think I changed this to a plus, so we're going to make this a plus 1/2, just so we can do a phase shift to the left instead. So our A value is 3, our B value is pi, our C value we're using as minus 1/2 because we're going to do the left. So again, I changed that, and I'll change that on the paper. And our D value is -2. So the period would be equal to, so the B times the period equals 2 pi. So the period equals 2 pi over B, which is pi. So the period equals 2. So the key points equal 2 divided by 4, which is 1/2. So in this case, our pi's canceled out from the B value. So this would just be 1/2, and 1/2 plus another 1/2 is 1, and then 3/2, 2 would be that 4/2, 5/2, 6/2, 7/2, and 8/2, and just reduce it. Make sure to reduce it on your x-axis. So let's see, the y-axis, I'm just going to go by 1 scale. And so our midline here is at -2. And then my graph is a cosine graph, so normally cosine starts above the midline, so up 1, 2, 3 from the midline. So it normally starts here, but because of our phase shift, we're moving it to the left 1/2. So instead of starting here, we're going to start our graph right here. So I'm just going to circle that and erase this one. So then from our above our midline, we go back to the midline, 3 below, back to the midline, and 3 above. So that would be 1 cycle. So if I continue that pattern, I would get a second cycle. So then we have 2 cycles graphed, and of course we could continue this if we wanted to. So that is it for our phase shifts and graphing. So again, the new thing is just moving your graph left to right based upon what your phase shift is. And if it helps you to do the transformations, it's fine. Just remember that your B value horizontal stretch or compression is already done, because when we change the units on your x-axis, that's the step that you're already doing. And that is it for today.